All right, let's go ahead and take a look at that first problem. So you can tell we have basically the types of problems you're going to have is going to be an MRP problem, a bill of materials problem, economic order quantity, and use vendor and a reorder claim. So those are kind of the 5 basic types of problems that you're going to have. I want to just do a little refresher course because I'm not sure that we had much to do with scheduled receipts when we did your homework. And so if you look in the upper left-hand corner, this is an MRP record for a bicycle frame, okay? And so what it's telling us is that we have a lead time of 2 weeks, that we have 0 on hand, we have 0 safety stock, and it's a lot for lot. So I gave you about the easiest type of MRP record that you could deal with, okay? Because it is strictly lot for lot, all right? But the deal is, since there's no inventory on hand, and my lead time is 2 weeks, and I need 70 the first week, that would be my net requirements, but I can't back it up 2 weeks, right, because I'm already there. So we're going to assume that somebody's already ordered that, and we're going to identify that as a scheduled receipt, okay? And again, our lead time is 2 weeks. Let me draw. So a lot of times I'll look for the lead time, and then I'll draw like a line right here so that that's my reminder that anything before that has to be a scheduled receipt, and anything after that I have to then have a planned order receipt, okay? And so again, I would look at this and I'd say, well, I need 67, that would be net requirements. If I try to back it up 2 weeks, right, I don't have 2 weeks, so it becomes a scheduled receipt, all right? And my available inventory, because I'm ordering exactly what I need, is 0, okay? And so then I come to week 3. My gross requirements are 97, right? So I don't have any previous inventory, so that means my net requirements are 97, meaning I need to plan for a receipt to come in at the beginning of that week for 97, and then I need to back it up 2 weeks to release my order to my vendor, right, so that I get what I need in, okay? And so what I know is that after my 2-week lead time, I am never going to have any more scheduled receipts because they then become, that's when you have your planned order receipts. So I can put zeros in. So before, I can have scheduled receipts before my 2-week lead time, but afterwards it's got to be zeros, okay? And my available inventory in lot for lot is always going to be what?
0.
So I can just go 0, 0, 0, right? If you leave it blank on the exam, I'll assume, if you've attempted the problem, I'll assume that if you leave it blank, you mean for it to be a 0, okay? All right, so then in week 4, Callie?
97.
97 is my net requirements. Morgan, what am I doing next?
Putting a planned order receipt for 97.
Right, and then Taylor, what am I doing next?
Backing it up to week 2.
Okay, backing it up to week 2. Okay, so what am I doing here?
87.
87 is my net requirements. Okay, Anna, what's my planned order receipt?
87.
87. Xander, what am I doing next?
Backing it up to week 3.
Okay. Backing it up 2 weeks to week 3 for 87. Kyle, what happens next?
77.
77.
77.
77.
Back up to 87.
Right, I think you've got the hang of it, right? 80, so we'll just 87, 87, back that baby up 2 weeks for 87, right? 97 net requirements, 97 planned order receipt, 97 for planned order releases, okay? The key, watch your lead time. I'm not sure, I don't remember what the exam problem is, whether it's a lead time of 1, 2, or 3 weeks, but just make sure that you pay attention to that information in the upper left-hand corner. Are there any questions about kind of this basic MRP record?
No, you don't have 9 or 10, so you can't do those 2.
Right, so I just leave those blank.
I
Okay?
got you, man. I will help you pass this test.
Okay, so then we've got the bill of materials question, and it says end item A is made by assembling 2 parts of B and 4 parts of C. Part C is made from 3 parts of D and 2 parts of E. Gross requirements for end item A are 100 units. Draw the bill of materials product tree and complete the second table below. Okay, so I've kind of, let me just space this just a little bit better. Okay, I'll go ahead and draw the product tree because I think it'll be hard for you to describe it to me, right? But it starts out, my end item is A. And my end item is made up of 4 parts of B, right?
2 parts
Two
B.
parts of B.
2 parts of B,
Or C.
and 4 of C. Okay? And then it says part C is made from 3 parts of D and 2 parts of E. Okay? And just to so I want to insert, and I'm just going to grab an arrow, and so I can draw my arrows, boom, boom, right? And then a lot of times what I'll do if I'm doing it this way is I'll just copy and paste that arrow however many times I need it. So I need it 1, 2, 3 more times.
We got units on hand.
Okay. So then I grab it and I say, so A looks like this, right? And C is made up of the 3 Ds and the 4 and 2 Es, okay? All right, and then it tells me that my gross requirements for end item A are 100 units. So I'm gonna go ahead and enter 100, okay? I look in the table up above and I have 50 units on hand. So, Tyrus, what's my net requirements?
50.
50, right? Aaron, what are my gross requirements for B then?
It'd be 200.
Okay? It would be if my gross requirements for B were driven by my gross requirements for A, but they're not driven by gross requirements, they're driven by what?
Oh, the net requirements, that's right.
Yep.
So it'd be 100.
Yep. So I'm gonna need to take equals, and I'll go ahead and put it, is equal to 50 times 2, which is gonna then say that we need 100, right? And Kirsten, how many do I have on hand?
30?
And so then therefore my net requirements for B would be,
Would be 30 or 70?
would be 70. Because I need 100. So what you need to understand is the definition of gross requirements is saying in total how many do you need? And then you need to compare what you have on hand and subtract those out to get your net requirements. So then it's going to be 100 minus 30, which is going to be 70. Okay? All right? Caitlin, for part C, okay, what is my gross requirement for part C? First off, tell me what it's driven by.
It is driven by, is it by A?
It's driven by A. Which part of A? Gross requirements or net requirements?
The net requirements?
It's driven by net requirements. So I'm going to say for C, I'm going to take my net requirements from A, and I'm going to multiply that times what?
2.
Fine.
Oh, hold on.
That's okay, times 4, which is going to say that I need 200 for gross requirements, okay? Matt, how many do I have on hand?
75?
You're Matt, right?
Mm-hmm.
Yeah, so, sorry, this Matt.
Sorry.
That's all right.
Paying attention, but I guess 75.
Good answer, good answer. Okay, so, but now I want you to tell me what my net requirements need to be.
Oh, man.
Not hard, how do I figure it?
This 200 minus 75.
Okay, that works for me. These tells me that I have 125 net requirements, okay? All right, let's go back to Joe. What are my gross requirements for D? What are they driven by?
The net requirements for C,
The net requirements for C. So my net requirements for C are how much?
125.
And I need 3 for every C. I need 3D for every C, so 125 times 3,
375.
right? Okay. And let's just keep going, Joe. How many do I have on hand?
100.
And so that means that my net requirements are what?
275.
There we go. All right, Morgan, help me do part E. What am I doing with E?
Taking
the C 125.
The net requirements of C, because I'm looking over at my product tree and I'm seeing that E comes from C, so I have to get my net requirements from there. 125 times how many?
2.
2. Says I need 250. How many do I have on hand?
75.
Right? So then it's going to be 250 minus 75 tells me that I have 175 that I'm going to need. Okay? So that's your bill of materials. Matt?
Could you explain how you got D and E again one more time, please?
Sure. So, and if you're just generally speaking from one level to another, so how I get D and E is I look at what's the part number, what are they dependent on, okay? So D and E are dependent on C, so I need to know the net requirements of C, and then that tells me how many of the D's and E's I need based on those net requirements, okay? So it's always that so at the top level of A, we're figuring out what our net requirements of A are. Those net requirements of A drive B and C, right? And in my product tree, I can see that part C is the independent, or it's not really the independent, it's the parent. We call that a lot of times the parent and child relationship. So C is a child of A, but D and E are a child of C. Does that make sense? Okay, and so then it's the net requirements of C that drive what the gross requirements for D and E. Okay? Any other questions? All right, let's go ahead and turn the page and we'll look at an EOQ. So this is going to be similar to the homework that you've been working on for Part C, okay? And so basically, let me scroll back up. So let me, Merge and center. Okay. So what we're saying is a manufacturing firm has been offered a particular component part it uses according to the following discount pricing schedule provided by the supplier. So it says if I order from 1 to 199, I can get a price of $79. If I order 200 or greater, I can get a price of $64. Okay, so the manufacturing company uses 500 of the components annually. The annual carrying cost is 20% and the order cost is $200. I like to start these by just starting to, so you'll see on your back page you've got a formula sheet, right?
What?
So, oops, sorry, you don't. There is a formula sheet that goes with it, and so you'll be given the, yours
On the very
does,
last
mine
page.
doesn't. All right. All right, that's good news. So Miranda, if I'm going to calculate EOQ, which formula am I going to be using?
What you start out with, like the one that says the Q model optimal or economic order quantity.
There you go. So if I'm going to calculate EOQ, what are the variables that I need for that formula, Miranda?
Like you want me to
Just read the variables to me to start with.
You need D, S, and H.
Okay, all right. And so now, given what we've, in this thing, the manufacturing company uses 500 components annually. What variable is that?
Is that D?
That's D, okay? And the annual carrying cost is 20%. You know what that represents?
Is that H?
It's part of H.
It's like you do that times,
So H is
200?
also rewritten as the interest times cost.
yeah, so times 200.
Okay, so here's what we're going to do for now, though. We're going to go ahead and put the interest rate variable here. So that interest rate is what?
0.2.
0.2, okay? And the order cost is what variable?
200. Oh, it's C.
Nope.
Oh, order cost is S.
Order cost is S. So, and then what is the cost if I'm going to do the EOQ for 1 to 199? What's the cost?
79.
79, right? So as I start to do this first one for $79, I have all the information I need, right? And so I can go ahead and I'll just go ahead and do A right here. And so to do EOQ, and again, I'm going to label these so that I can keep track of what I'm working on. So at $79, at that price point of $79, it's going to be the square root And if I'm doing it in Excel, and you won't be on the exam, but for here, I go ahead and put a parentheses around everything I want to square root, and then I parentheses the numerator and the denominator. So my numerator is going to be 2 times my annual demand of 500, right, times my setup cost of 200, close the parentheses. And then I'm going to divide it by, open parentheses, the interest rate times the cost. And so in this case, it's 0.2 times 79, close the parentheses for the denominator, and close the parentheses for the square root. Okay? And so you can see, you've got the formula. I didn't copy and paste the formula in here, but you've got the formula for that on your formula sheet, right? And so if I'm going to calculate that, I can just remove that apostrophe that makes it a label. And it comes back at 112.5. Or we would say 113. Okay, does everybody tracking with the economic order quantity and how we read the information from the problem and are able to pull that out?
If we put 112.5, are you gonna count it off?
No. No. So the question was, if you put 112.5, will I count it off? And I won't. Okay? All right? And then Hope. Let's do the EOQ for the $69. So can you read to me what that formula, it'll be the square root of what?
You mean 64?
Yeah, sorry.
Oh, yep. I do. I'll fix it when we get done with the formula. Okay?
I'm sorry, what were you asking me?
So can you help me with the numbers? So it's going to be 2 times annual demand times setup costs. So it's 2 times what's my annual demand?
200? Oh, sorry, 500.
Times the setup cost of,
200.
close the parentheses, divide it by my holding costs, which are going to be what times what?
20% times 64.
Times 64, right? And then I'm going to close that parenthesis. And I'll fix this real quick. I'll remove the apostrophe, and it will tell us that that says 125, okay? So now tell me, Blake, is EOQ at 79 feasible or not feasible? So we have 113 at a price of 79. Is that a feasible solution or not feasible solution? Were you here on Monday? I can't remember.
Yeah, I was.
Okay. What makes it, somebody help us out, what makes it feasible or not feasible?
It's within the range.
It falls within the range.
So it's got to fall within the range.
that's the number I
So
was
does so our range is 1 to 199. So does 113 fall within that range? So
Yeah,
that is
yeah.
feasible. Okay. How about for Part B at the price of $64? It is not feasible. Okay. So for our comparison, what's the quantity that I would need to allocate in order to do the price discount comparison? If I can't order in a quantity of 125, what is the quantity that I'd want to order in for that price discount?
200 or more.
200, right? So we're going to select then the lowest possible order quantity at the lowest, or at this price, right? Which is equal to 200. Okay? And so that's when we move down and do our total costs, right? We're going to have to do total cost for a feasible EOQ, and then we're going to have to do total cost using our price discount, and we'll use 200. Okay? And so when I move on to B, and I look at total cost, probably we'll have seen this a bunch of times at this point, but total cost is equal to purchasing costs plus carrying costs plus ordering costs, right? And so if that's the case, if I'm going to redefine that in terms of variables, it's going to be purchasing is annual demand times cost, right? Plus carrying costs are my average inventory of Q divided by 2 times my holding costs, but in this case our holding costs are broken into interest rate times cost, right? Plus our ordering cost, which is how many times you reorder, annual demand divided by Q, times our setup costs or our ordering costs. Okay, so those are our formulas that we're going to use. And again, you can look, they're listed on your formula sheet, so you can reference back to that. Okay, and so then to fill this in, again, I like to keep myself honest. So these are going to be the variables I'm going to use for the feasible solution, right? I have a cost of 79, an interest rate of 0.2. So I would put in then for that equation, for total annual cost at $79 at that price, it's going to be annual demand of 500 times the cost, so it becomes a plug and play, right, times 79, plus my quantity. So what's my quantity at this price? Mike, what's my quantity that I'm going to be using in this equation?
113.
113, right? Plus 113 divided by 2 times interest of 0.2 times the cost of 79 plus annual demand of 500 divided by my quantity again of 113 times my setup cost of 200. Okay, and if life is good, if I copy and paste that and remove that apostrophe, it should calculate for us. And that tells me it's 41,277.66 cents. Okay? So that's my total annual cost if I purchase at $79 and in a quantity of 113. Okay? So I probably should put over here that my Q is equal to 113. Okay? So if I'm going to do C, where it says calculate the price discount using the price discount we're given, right? I can copy this down. And Matt, in the back row, Matt, what changes between B and C? Is my annual demand the same?
Yes?
Is my setup cost the same?
No.
Yes, it is. Okay. How about my interest rate?
Yes.
Okay. What about my price?
Same.
It changes.
Changes, yes.
Right? So my price goes from $79 to $64. So I put that in for C. And what's my quantity that I'm going to order in, Matt?
113?
Nope, because that's my EOQ for the first one, for the feasible one. What
Oh,
it
the
is-
125.
Okay. Is that right? How many of you would put 125? You're not going to raise your hand because you know it's wrong, right? Okay. So why wouldn't it be 125? Somebody help me out with that.
Because it's
Because it's not
only,
feasible.
yeah, it's only feasible when it's 200.
Right.
It
It's got to
says,
be, you have to order in quantities of, at a minimum order quantity of 200 to get that. So, and I do that purposefully because there'll be probably 5 or 6 of you that will do that on the exam. Okay? So just know that when you go to the price discount and you're not in a feasible solution, you have to go up to the minimum order quantity. And so the minimum order quantity, what we said is it's 200, right? So then our quantity becomes 200. And now that we've clarified that, right, it becomes a plug and play back in that total cost equation. So my total annual cost at 64 is equal to, and remember I said you have to substitute 2 Qs and 2 Us, or 2 Qs and 2 unit costs, okay? So I'm going to substitute out, right, my cost here and here, and the quantity ordered here and here, okay? So it becomes 500 times 64 plus, I'm going to order in a quantity of 200 divided by 2 for my average inventory, times my holding cost of 0.2, times my price of 64, plus my annual demand of 500 divided by Q of 200, my ordering quantity, times 200, which is my setup costs. Okay, and again, if I've done this well, I should just be able to copy and paste that and remove. Right, so it says 33,780. Okay, Adam, given that I have total annual cost of 41,277.6 and 33,780. Which one am I going to go with, B or C?
Is it C?
Yep,
Cheaper?
it's cheaper. And so then the question is, what's the order quantity that I'm going to use for that?
200?
200, right? And again, that's where, don't say, somebody is going to say 200 or greater. That's not right. Because why would you order greater? Because it's going to cost you more money. You're going to order the minimum amount that you can, price discount. Okay? Did anybody have any questions on that? All right. The next one is our news vendor problem. And again, if you look on the back page of your formula sheet, right, you've got the formula for the news vendor problem. So it says a product is priced to sell at $100 per unit and its cost is constant at $70 per unit. Each unsold unit has a salvage value of $20. Demand is expected to range between 35 and 40 units for the period. 35 definitely can be sold, and no units over 40 will be sold. The demand probabilities and the associated cumulative probability distribution for this situation are shown below. So then the question is, how many units should be ordered? Okay. The first thing that we need to do is we need to calculate kind of, remember when we worked on the news vendor problem, we identified the targeted p-value, which is the probability of units not sold. Okay. So if that's the case, and I go to that formula, right, it says that P is less than or equal to our C sub U, our cost of underselling, divided by the sum of the cost of overstocking plus the cost of underselling. Okay? If you remember, the cost of underselling is basically lost profit. I guess it's not underselling, it's understocking, right? Of not having enough is your lost profit. And your cost of overstocking is basically equal to the cost of buying or making minus, right, any salvage value. Okay? So in this case, my cost of understocking, any lost profit I have, Ryan, I think we're to you. How would I figure lost profit in this? So it says a product is priced to sell at $100 per unit and its cost is constant at $70 per unit. So lost profit is going to be what?
The 70 over 70 plus 100?
Nope, you're trying to leap ahead. Okay, all I'm trying to calculate right now is the cost to understock. Okay, so my cost of understocking is whatever lost profit I have, right? If I don't sell a unit, and so my profit is going to be my revenue minus my expense. So it's going to be if I have it's priced to sell at $100 per unit, that's my revenue minus my cost of 70. So my cost of understocking is going to be 100 minus 70. Does that make sense to you? Okay, so that means that my cost of understocking is 30. Okay, and next to Ryan, I'm sorry, I don't recall your first name.
Tyler.
Tyler. Okay, so my cost of overstocking, Tyler, is the cost of buying or making minus the salvage value. Okay, so the cost is constant at $70. Each unsold unit has a value of $20. So how would I calculate my cost of overstocking?
100 minus 20?
Nope, because that's revenue, right? And so I'm just interested in, because if I have the cost of overstocking, it's basically the cost of the product to make it minus whatever salvage value I'm going to have, okay? And so it says, and its cost is constant at $70 per unit, okay?
70 minus 20.
There you go, 70 minus 20.
Which is 50.
There we go. All right. So that's kind of the key to this one, and then once you get cost of understocking and cost of overstocking, it's a plug and play into the formula, right? And so what I'm going to do is I'm going to say that it should be then equal to 30, right, divided by 30 plus 50. according to our formula. Ex-
Plus 50.
Cost of understocking is 30. So yeah, to be consistent, we'll go 50 plus 30. So this is a lot like, remember the, kind of those homemade pies that we worked on, those problems that we worked on? So our probability of not selling that we want to target is the 0.375, okay? So there are a couple of ways to get at this. Did anybody come up with a good way to think about which one of these you're going to target? No? Okay. So this is your probability of selling them, your cumulative probability of selling them, and your 0.375 represents the targeted probability of not selling them, okay? And so there's two ways to get there. The first way is to say, well, my probability of not selling less than 35, we're going to say is 0. So you go, okay, well, there's 0, okay? Well, so 0 is definitely less than 0.375, right? So then my probability of selling less than 36, right, is 0.1. Okay, my cumulative probability of selling less than 37 is 0.25. My cumulative probability of selling less than 38 is 0.5, right? So when do I exceed my targeted value of 0.375?
At 37.
I exceeded at 38, so then I would say I would target 37. Okay? I think that's the trickiest part of that problem. If you get the probability right, it'll probably just be a point or so deduction for not getting the right response there at the end. But and then the alternate way to do it is to say, okay, well then, if 0.375 is my probability of not selling,
That's exactly what I did.
then 1 minus 0.375 is my targeted probability of selling. So I can spell it, probability of selling, right? And so then I look at that 0.625, right? And again, 0.75 exceeds that, and so I would drop back to the 37 and say my targeted quantity is 37.
That's way easier.
So you can select one way or the other, okay? All right. You just might have to think that one through and come up with talk yourself through how you're going to decide where to hit that range. And that might just take a couple of times of looking at that problem for you. All right, and our last problem that we're going to look at is a reorder point. Okay? And again, you've got the reorder point formula on your formula sheet. Okay? And so our problem says, consider an economic order quantity case where annual demand is 1,000 units, economic order quantity is 200 units, the desired probability of not stocking out is 0.95, the standard deviation of demand during lead time is 25 units, and the lead time is 15 days. Determine the reorder point and assume the demand is over a 250 weekday, and in this case, and I'm just going to give you the Z value because you don't really have the resources to look it up on the exam, it's 1.64. Okay? So, from that, I'm just going to copy the variables out of that, because at this point you should be pros at coming up with those variables. Demand is 1,000, annual demand is 1,000, order quantity is 200, that targeted probability of 0.95, your standard deviation of lead time is 25, your lead time is 15 days, working days per year is 250, and Z is 1.64. Okay? So if that's the case, and from your formula sheet, you know that your reorder point is small d, right? And so I call that d bar, times your lead time, plus z times your standard deviation of lead time, okay? And I'm not making you calculate anything unique in terms of the standard deviation, like what you had to do on some of the homework problems. It's just going to be given to you straightforward, okay? So if that's the case, I think, Callie, we're back up to the front. The only tricky thing is I have annual demand of 1,000 and I need D-bar. How am I going to get D-bar?
1,000 minus 200.
Nope. So D-bar is going to be my average daily demand. Okay? So D-bar, so small d represents average daily demand. So given what information I've got in the problem, how do I come up with what my average daily demand is? Tyrus?
You divide 1,000 by 250.
Right, so I'm going to divide my annual demand by the number of working days in a year to get my average daily demand. So 1,000 divided by 250 gives me D-bar. Okay, Morgan, what's my lead time? 15 days, right? And then I'm going to add to that, Taylor, what's my Z-score? 1.64 times my standard deviation of lead time times 25, right? And at the end of the day, I calculated this correctly. Leaves me with 101 as my reorder point. Okay? Any questions on that? All right, so I'll post the blanks and I'll post this Excel file and I'll post the recording. So if anybody wants to run back through it, you're welcome to do that to prep for the exam. And again, I'll be in my office on Friday from 11:30 to 12:20. So if you have questions, bring up questions in, or get my regular office hours. So with that, have a good weekend. Right?
Thank you. That's you too. Good questions.